Hey, Aloha Friday to everyone. Happy Admissions Day to you. Today, we've got a pretty good show lined up for you, and it starts with one of the most fundamental things I think you have to talk about when you talk about picking up renewable energy and doing renewable and becoming cleaner and greener, and that's efficiency and being efficient at first. So for my straight voltage for today, I'd like to talk a little bit about change, but not a whole lot. That could be a whole show by itself. But I was once told by somebody, a very wise man, that the only person that likes change is a baby that has a dirty diaper. And that's probably a good quote. Most people are kind of averse to change. And a lot of that's because we've developed habits. You know, we're used to going into a room and flipping on a light switch and then walking out of the room and leaving it on, or turning on the TV and then walking out in the yard and doing yard work and the TV's still going. And so we've developed some bad habits. And one of the things that keeps us from developing good new habits is we just don't recognize it. So our guest today is gonna kind of show us how they do it on the professional level with big buildings and with smaller buildings, even residents, on how we deal with energy efficiency and kind of break some of our bad habits. But it's not just on and off switches. It goes into bigger things like entire systems. And that's what we really want to talk about with this straight voltage minute. It's not just break our own personal bad habits, but let's look at the big institutional habits and the way we do things. Is the grid the right way all the time? Is driving your car using gasoline the right way? Or are there other ways of being more efficient and more conscious of the energy that we have and using it smarter? So the first thing you do, and Ray Starling will tell you this on Wednesdays, the first thing you do is look at efficiency. So our guest today is Kyle Blickley from HNU, a good Maui company. And I like to do local companies on the show whenever we can, because it's great to see Hawaii companies doing things that actually have an influence across the world. And most people don't realize that Hawaii does a lot that's picked up on the mainland and picked up other places. And we don't appreciate it. I think we're just kind of I call it anti-tantanan. We don't like to make a big deal of it. But, you know, HNU is one of those companies that does some really good work. So Kyle, welcome to the show. Why don't you tell us a little bit about how you got involved in all this energy stuff and working at HNU?
Okay. Yeah, my name is Kyle Blickley, and I grew up in California and got a degree and went to school in San Diego, worked in the photovoltaic installation industry there, and then went back and decided to look back at energy management, focusing on buildings, not only because we were doing photovoltaic installations, but I wanted to start addressing the underlying issue of the energy usage. I went back to school and got a degree in energy management, master's degree from UCSB, Bren School of Environmental Science and Management, and then basically once I graduated, took that and came over to the islands here, and I got a job with HNU Energy based in Maui. So one thing that is really unique about HNU Energy is we are a vertically integrated engineering construction company. We work on design build projects, specialize in that in the commercial military sector, and we're really able to address the energy issue from multiple sides, multiple areas, and to address the efficiency of buildings, to address how to store energy, to make them more sustainably and more independent, and then to provide renewable energy sources to it. So we do research and development projects to gear technology up for commercialization, also do commercial and industrial PV systems to offset the load at buildings, and then address through efficiency a lot of issues there with inefficient lighting, inefficient control system, inefficient HVAC. So we provide comprehensive energy solutions for commercial and industrial customers. So.
Okay, so does HNU actually get involved like with the architect when he's designing a building and help him put the right things in the building, or do architects pretty much get that in the new school curriculums that they go through? Or do you find a range of some architects don't have a clue and some could really use HNU's help, and other ones really are akamai about how to use efficiency in their buildings?
I think we definitely, the key is to, especially for new construction, to be involved as early as possible and to be involved in design charrettes with the construction, because even building orientation can impact how a building performs in an environment. And so all those things are important. We try to interject when we can. We've worked with a number of developers that are looking at, really efficient off-grid communities and how to structure the buildings, layouts, how to optimize them, so that then, you don't need to have as intensive energy systems in the first place. And you can have smaller PV, smaller battery, more efficient design. So it does, we do definitely try when we can to be involved as early as possible. A lot of times what we're doing is retrofitting existing buildings. So with that, we have structural engineers on staff that can assist in how to retrofit it properly. We have electrical engineers on staff that can figure out how to modify existing systems to be more efficient and how to install energy efficient technologies and renewables. So it definitely, when we can, but we are also trying to address the existing building stuff that's out there, which is really
Yeah, I'm familiar with you doing the net zero at Hickam, but it's really important. I don't think people understand, and you mentioned just the orientation of the building. Blue Planet Research on the Big Island has a really nice lab out there. The whole, and Paul Pontieu, who designed the building, he has, the whole building is designed to support a PV array that maximizes the sunrise, sunset in that area to get the most out of this PV array. So yeah, you bring up an important point. The earlier that your company can get involved in the design maximizes your ability to use that PV or wind or whatever in the best way for your customers. Great. So HNU's on Maui. How did it get its start?
HNU actually started as a photonics-based company, and the CEO, president are optical scientists that worked on telescopes and mirrors and stuff, worked at Haleakala Observatory, and developed optics and mirrors actually that worked in energy harvesting for concentrating PV. So back in 2006, actually, HNU Photonics and HNU Energy were formed. And HNU stands for the power of the energy in light, and that's the Planck's constant times the frequency of light. So it's basically an equation there, but it's supposed to really mean, that I think that we take a scientific approach to developing solutions and commercializing. So based in Maui, we still have a headquarters there. We have a full machine shop, optics lab. We are actually still designing specialized equipment for all kinds of operations, actually working with NASA on a project right now for something that's going to be going onto the space station. So, and then working on a number of other projects in the R&D phase. But then aside from that, my team, the energy side, we develop and implement projects across the islands, across even in Guam. So we're doing that throughout and really focusing on energy solutions in island environments, and where there's small grids, where there's corrosive environments, where there's other issues, where you have to come up with innovative solutions. So it's sometimes the hard projects that we tend to tackle and come up with some really innovative solutions.
So HNU likes the challenge.
We like a challenge, yes.
Okay, great. Well, it sounds like you get into some pretty sophisticated stuff that went right over my head. I have no idea what those physics terms and stuff are, but I do get into the practical side of it. And what you really do saves energy at the front end. And even when you look at our Hawaii Clean Energy initiatives and how they started, the first piece in there was go for efficiency. There was a component in there that said, we go efficiency, and then we also reduce fossil fuel consumption on a timeline. And that's a pretty consistent theme. So the whole idea of either maybe using solar water heater and solar photovoltaic on your house, because your solar water heater, if you're using an electric water heater, does pull a lot of power. Those are the kind of things you look at. Even at a residential level, you can actually design and retrofit houses to be a lot more energy efficient and help the customers save some money at home.
Oh yeah, definitely. So there's so many options there, and I think a lot of it is even just not a customer understanding where their energy goes. So one of the things we do is we'll provide a package, a monitoring package that can be installed so that a customer can see, I'm seeing that my water heater's been running this often, or these plugs, this computer's been running for this often, so you can take it down to the circuit level and see what's going on, because a lot of times customers don't know where their energy is being used. So So we do that in the residential side, and then also do that in the larger scale, and identifying where the energy is going. We did that at Hickam. We looked at, we've had for quite some time now, monitoring on all of the circuits so we can see what goes into all the lighting, what goes into the HVAC, and then we can start to figure out what solutions are going to be the best for them to reduce their consumption.
Okay, so some of the things you've already talked about. So you look at the circuitry in the building, maybe even recommend to an electrician how to rewire a building potentially to save some electricity. You've looked at how much a particular appliance is used, like a water heater, and how you can save money there. You talked about lighting. There's a lot you can do with lighting, with LEDs and different lighting now that's a lot more efficient and gives you a lot more light for the buck. Photovoltaic on your roof to produce electricity. How about some energy storage things? Do you do anything in energy storage?
We do, and that's one of the things that we've been developing in the research and development phase at our company, and bringing that, commercializing that, and actually building, from in a scalable solution, energy storage systems that can basically be added to an existing PV system, and will allow residents, commercial building, to essentially run, either partial or total off-grid. So there's options out there. We're actually working with a number of people and working with some customers in Maui where they don't have a connection to the utility. So we're installing a lithium iron phosphate battery storage systems in the ones that we've designed, built custom racks for it, battery management systems that we've integrated in, and like 8 kilowatt hour units that can be installed, that can be stacked, so you can do 24 kilowatt hours for a residence. And Tesla is putting out similar products. We're developing and building these here on Maui, so it's very local development. So it's been very exciting. We've had people that have been interested, and really now the prices have come down enough where that's very affordable for a lot of people, especially that want that security, so.
Okay, we're going to take a quick break, but when we come back, I want to talk to you more about batteries and talk to you a little bit more about Tesla and what they're doing with their batteries. But we're going to take a quick break right now, and we'll be back in about 90 seconds. Thanks a lot. We'll see you in a few.
Aloha, I'm Keli'i Akina, president of the Grassroot Institute and host on Ehana Kako, a weekly program on the ThinkTech Hawaii broadcast network. Ehana Kako means let's work together. Think of the sad alternative, let's not work together. Here in Hawaii, with all of our diversity and the richness of the people, it's important for us to come together around issues on the basis of what's right and what's good and what's going to serve the common good. And that's what we try to do at Ehana Kako. Every week we interview movers and shakers, people in government, business, and other sectors of society to talk about how to create together a better government, economy, a better world here in Hawaii that can bless the rest of the world. I thank you for your attention to ThinkTech Hawaii, and we look forward to seeing you every Monday, 2 to 3 p.m. on the ThinkTech Hawaii Broadcast Network. We're Ehana Kako, and we wish you well. Aloha.
Hey, and welcome back to the Power Lunch on Aloha Friday, Admissions Day here in Hawaii. I'm Stan, the Energy Man, and we got with us today Kyle Blickley from HNU on Maui. He's been telling us a little bit about how his company started and how they make energy efficient buildings from scratch or help you retrofit buildings. And we started talking a little bit about batteries, and I've actually had a busy morning this morning talking to some companies that do some new technology. And one of the companies is taking automobile batteries that have kind of reached the end of their useful life, and they're recycling them into more home use storage batteries and things like that. So that's always intrigued me, because I always worry about batteries at the end of their life. What are you going to do with them? Because they're heavy metal materials. There's a lot in there that you don't want just dumped into your landfill, and they have some disposal issues with them. So there are companies out there that are giving second life to batteries that can go back into facilities or to residences and provide the kind of storage that you would use in a building. But say I invited you over to my house and I said, okay, Kyle, take me from beginning to end. What can I do in my house? What are the kind of things you would look at in my residence and start off with, and kind of walk us through your process as you're going to retrofit a building.
Okay, so yeah, if we showed up at your house and you were interested in figuring out how to retrofit that, we'd start by looking at the energy usage that you've been experiencing there, whether it's electric or gas and all those, and then identifying your major pieces of equipment there that you are using to see how efficient those things are, and then looking and seeing actually if we can do some maybe monitoring of the usage there on a more finer resolution, and looking at stuff like your insulation. Is your house, if you're using HVAC extended period of time, are you well insulated? How efficient is your HVAC system? Are your windows well insulated? Is there loss of air escaping through areas? So there's tests that we can do. We can check use a blower door test to test the how tight your building is, because if you are running HVAC, that is, you want to have a tight envelope. So if you're, using trade winds as your primary means, then, are your windows optimized for that? Are you getting the right ventilation, taking advantages of, natural breezes and stuff? So there's, looking at that, and then addressing lighting, especially lights that are used more frequently. Those ones you'd want to look at replacing first with energy efficient lights. So the more that you use those lights, the more benefit you're going to get from using a high efficiency light, and replacing like halogens, replacing some of these sodium lights that are very energy hogs, and they also create heat. So you've got other issues there, if you
you're making heat and you're trying to air condition your house. It's
Exactly.
kind of counterproductive.
So unless if you live in a cold climate, which we don't here. So there's a number of things you can look at, and looking at photovoltaic systems. You can look at photovoltaics that actually help to cool the roof as well. If you optimize that, but there's a number of techniques to kind of go ahead and try to get you as close, and really it's totally doable. You have good, southern exposure to install a PV system that will take care of your load, especially if you're not using a significant amount. And if you want to, you could do install a battery storage system. So the inverters, we specify inverters that convert, the sun power to usable electricity, that also work with the batteries that we have, and so that way you could disconnect from the utility altogether. So there's a number of efficiency side measures that are really important. A lot of here it's lighting, HVAC, and and having a nice tight envelope on the building.
Do you find that things like putting film on windows, reflective films, help certain residents or businesses a lot? Or?
Definitely, yeah, especially west-facing windows that are going to get a lot of heat in the afternoon. So maybe the east-facing isn't as critical, because you're not as worried about the overheating in the morning. Even putting window like shades over certain awnings and fins on west-facing. So there's a number of things. Even planting trees in certain areas to try to give you a little extra shade. So there's a number of ways to kind of offset some of those issues that are going to use energy.
Yeah, I think a lot of people miss some of those things, like the agriculture side or arbor side, to have somebody put a tree in the right place. I mean, we kind of know it, because if you have trees around your house that don't make all that rubbish, they're kind of nice, because they do cool your house down quite a bit. And where do you plant the trees to make them, they don't block the wind, but they give you the shade? Those kind of things I don't think a lot of people really put a lot of thought into. And that was kind of my point when I started the segment off, is it's more than just bad habits that we have. I mean, we don't think about where we're planting a tree other than it would look pretty there, But maybe when you're landscaping your yard, that could play a huge role in how efficient your house is. That's a good point. So you brought some visuals with you too, right?
I did, yeah, and I brought a video showing one of our recent projects in Maui. We're actually installing a large solar carport at the University of Hawaii Maui College. So I brought a couple of minute video clip showing the construction of that, and kind of shows how our process of designing and installing, or I can explain the design process when we start watching the video.
Okay,
So
great. Yeah, we'll be talking over the video and explaining what's going on.
Yeah.
Yeah.
Stations underneath. This is located very close to the ocean on the windward side. One of the real challenges here is that they wanted carports that had no ferrous metals exposed. So because they got so much salt air coming in directly off the ocean. So as you can see, these are precast concrete carport structures, and then extruded aluminum parts connecting everything together. So it's either a precast concrete, aluminum beams, or stainless steel parts, so hardware. So it was a feat to to design this system, withstand the winds with a precast system that, and then the building has the inverter and everything located within it to prevent it from corrosion. So this system is, and actually right now we're going ahead and installing a 4th row at this very moment. So we're moving forward on expanding the size of the system. And this will basically take care of their base load at the whole University of Hawaii Maui campus.
Wow, their whole base load?
It'll produce up to their base load.
Wow.
At times. So it's not overnight.
Right.
It's a system that doesn't have a storage component to it. But that's something that we can look at later, because we could add more, add storage, and then they'd be able to discharge from the solar at night. So this is a grid-tied system. So but it's providing a significant amount of their usage.
You know, I kind of knew you were doing this project, but what I didn't understand, and it's huge, is that because of the location of this facility or their campus, corrosion is a big issue, like at Kaneohe Marine Base and Kailua. I mean, I have friends that live in Kailua near the beach, and their air conditioner, they just throw it away after 18 months, because no matter what you do, it's going to rust to pieces, and even the aluminum will anodize and just fall apart. So the idea of using concrete, so it's pretty solid, hurricane proof and everything else, and then introducing the PV on top, and that's a substantial load. You're basically giving the university ability to zero out their electric bill, although they're connected to the grid, but you're giving them a pretty substantial amount of power for their utilities.
Yeah, I think, overall it provides, when the PV system is producing full output, it can provide up to the usage of the building at night. Where it's still being drawn from the utility, but it's a pretty substantial amount, and it's been great for them, because they've got now shaded parking along this whole section of parking lot. So it's turned into very valuable parking stalls. We also put in electric level 2 or level 1 and level 2 electric vehicle charging stations there. So there's kind of premium spots there for electric vehicles to park, and then they can draw directly from the same circuit.
I can tell you, on weeks like we've had lately, that covered parking is like priceless.
Yeah.
You get out to your car, you're frying right now. So that's another good point, though. These systems can protect your house and cool it down probably 5 or 10 degrees just by having PV on your roof. And then when you provide covered parking for a campus like university and give it back some energy, that's a pretty good win-win for the folks going to UH Maui.
Yeah.
We've talked to several of the UH campuses, and they're very supportive of doing these kind of initiatives. And is Maui going to try and do some more, maybe put some on their buildings, do you think, or have they talked to you about that?
They, I'm sure they're interested in doing more. I think, they've got plenty of parking spaces, and so our parking lot area. So, we've talked to them about adding additional rows there in the carport. I mean, they do have some PV already on their roofs. We're focusing on utilizing that space there, but they do have a few other systems installed, smaller ones, but we're really able to kind of keep everything very condensed in that one, and basically create an energy farm there in their parking lot. It's been great. there's other opportunities to work with them on projects that we'd love to be involved with. And other campuses, you know, we installed 500 kilowatts at Hilo. So we have installed on numerous roofs there. I've also installed a system at University of Guam, and that was 100 kilowatt, but installed on 5 different roofs, and that was actually 5 or 4 different types of modules. So it's almost designed as a test project, different inverters and modules. So we've been getting data from that. So, and we're looking at working with them on a much larger project as well, meaning blanketing all of their buildings. We'd love to if we can. So, so there's a lot of great partnerships, and I think everybody sees the value of this. And you know, the design, precast concrete, you know, we build those on Maui. We use local resources to do that. We do all the structural and electrical engineering in-house. So it's and we have a great system, you know, in place for these really corrosive environments. So that's what we do. You know, rooftop systems as well, projects in throughout Hawaii and Guam.
Okay. What are some of the projects you're doing on Guam? I mean, how big are they? Are they military projects or commercial?
Right now we're installing a project on the new hospital there. It's a Guam Regional Medical City. It's a 400 kW roof-mounted system in the process of that installation. It's a brand new building. It's just in opening, so we're installing all the footings, getting that prepared. It's going and actually working with the utility there. Is, you know, they actually look to Hawaii for a lot of guidance. So we're actually, you know, trying to help GPA, Guam Power Authority, to figure out solutions for, you know, integrating PV, rooftop PV, and other stuff. So yeah, and then we're looking at other opportunities. We've done actually a number of LED lighting retrofits in Guam. Nissan dealership in Guam is fully retrofit with all LED lighting. So that's been, and we have a level 3 electric quick charger there at the Nissan Guam dealership that we've installed. So we're trying to also focus in Guam on these comprehensive packages where we, you know, lighting side is huge, especially, you know, these high-powered, you know, 400 watt lights. We can reduce the size of those substantially. So
yeah, car dealers love lights. I'm not sure why, but they really do. They always seem to be lit up as bright as anything on the planet at night. So you've got University of Hawaii Hilo. Are you doing anything else on for the university system on Oahu?
No, the one thing that we are doing for the University of on Oahu is working with the Hawaii Natural Energy Institute, but that's actually a project on Maui.
Okay.
So we're doing, we're gearing up for a test project that's going to have 12 different types of systems, different panels and inverters that are going to be installed on a carport, and then we're going to do extensive testing of all the different types of panels and inverters to see what works best.
Okay.
So that's a project I've been working with Hawaii Natural Energy Institute based here, but it is a Maui-based project that we're doing. So, but we'd love to do more, you know, here on Oahu. We've done a number of projects here. Commercial projects, you know, solar projects in different areas, working with the Catholic churches here on Oahu, Palama Meets, Dorban Lay, Waianae Library. We installed some system there, different places around on the island. So definitely, you know, and I think the carport system is a very unique design that has a lot of great applications, especially in these windward side environments. So definitely. Staying busy, so that's great.
That's good. Like to keep the jobs going.
Yep.
Okay, well, we're about coming up on our break time, I think, and maybe when we come back from the break, we can talk a little bit about what you do at Hickam and the projects that you're doing out there with us and the Air Force Research Lab to get some things done. So we'll take another quick break, do a little bit of local advertising, and be back in a few seconds.
Aloha, my name is PJ, and I'm the host of Hawaii Sports Update. I am very interested in local sports, and that's why I host the Hawaii Sports Update show. I bring in guests from Hawaii, I bring in guests from UH, I bring in guests from the community, I bring in big names, I bring in small names, I bring in all names that are community related and doing positive things, sports related in the community. Come join me every Tuesday at 1 p.m. here on Hawaii Sports Update. You can also join me on my golf tournament, the first annual PJ Sports Radio Show golf tournament. It's going to be held at Coral Creek. For any information, go to ThinkTech Hawaii, INC, and friend us. The PayPal and a summary of the event will be right there available for you. And don't forget to tweet us.
Hey, welcome back to my power lunch on Aloha Friday, Emissions Day here in Honolulu. And we're here with Kyle Blickley from HNU. And he does a lot of great work around here. And we're going to talk a little bit about what he does for Hawaii and the Hawaii Center for Advanced Transportation Technologies, the folks that I work with, and also the Air Force Research Lab at Hickam. But we've also got some photos of some other projects that he's got going, and we're going to throw those images up and let Kyle just talk about them as they go up.
Yeah, so this is actually at Hickam Air Force Base, and this is a hangar for F-22, corrosion control and maintenance hangar. And what we've got here is we replaced all of the LED lights, or all the lights in the hangar with LED lights. So basically took the, and installed lighting control systems so that the lighting levels could be adjusted to those skylights that you see above. So we cut the energy usage from all the lighting in this building by about 60% with these measures. This is another picture of Hickam, and this is actually the HVAC system that was retrofit. And one thing is we redid all the duct work up there, and those boxes over there are variable air volume boxes. So whereas before that the air handler was just kicking out one CFM to the whole building, now it's being adjusted based on the usage in the building, based on occupancy. So we've got occupancy sensors set up and controls in different zones. So those are a couple of the just pictures of Hickam that we've worked on.
So the building you couldn't like shut down a room at a time, but now you can.
Now you can, yeah. With zone, it's like there's 4 zones within the space. So this is a picture that we've just recently completed at in Kihei, and this is a 500 kilowatt system on 2 buildings, carport and field up at in Maui High Performance Computing Center in Kihei Tech Park. So this is one of the roofs. We've got standing seam metal roof, and then panels located on a trellis that were installed. And this is a system that we were replacing panels with sun power on a dual axis tracking system.
Okay.
So this system is going to be tracking the sun throughout the day and changing its orientation over the course of the year.
Is that a concentrator PV or just straight panel?
That's just straight panels.
Okay.
So this is a system installed on the lower building, and the challenges here is that they had a very lightweight roof, but they didn't want us to penetrate at all, to drill into the roof. So this system is designed to provide wind deflection on itself with the way the panels are tilted east and west. And it's a very lightweight ballasting, so it's able to be acceptable by this kind of lightweight structure. So this is a 250 kW. This system is, as I mentioned earlier, at University of Guam. So this is part of our University of Guam project. And one of the things that was really cool about this is a lot of those workers that you see over there, they were trainees with the Center for Island Sustainability, that they came from outer islands in Micronesia to learn about how to install PV, and they were part of our install team. We're training them how to install
so
that.
like a jobs training program.
Jobs training. So yeah, that's the finished system at the Computer Center in University of Guam. That's using a polycrystalline silicone module.
So did you go and do, on some of these projects, did you go and do energy efficiency in their buildings before you did the PV? Is that a standard part of HNU's process?
Whenever we can, we do. You know, that's definitely, we go in there and we look at, especially, you know, focusing on lighting improvements and doing energy monitoring for them. You know, a lot of times we will do whatever we can, and a lot of times we'll put the PV, get that going, and at least make recommendations on the efficiency improvements so that they, you know, the system's sized properly. So we, you know, we work pretty heavily in the lighting side, and you know, in projects like Hickam, where we're able to work on the HVAC system as well. So so we do, you know, when we can, with the right customer.
Let's talk a little bit about that lighting system in the hangar that you showed there, the F-22 hangar, because, you know, I've worked with you on that project. And some of the interesting things that I learned from you and from HNU is that, you know, we had things built into the building to give natural light. There's skylights there, but right next to them were high-powered, what are they, sodium lights?
Metal halide,
Metal halide lights. And those things had such a long cycle time that once they were turned on, nobody wanted to turn them off, because when you turn them back on, it took 20 minutes for them to come back up. So they just turned them on and left them on all day, even though the skylights were actually letting in a pretty good amount of light most of the day. So about how much power did it save to just take those lights out and throw in the LEDs to replace them? And what other advantages were there to the LEDs?
Yeah, well, definitely the huge advantages besides just the efficiency improvements. So all those lights, they were 400 watt, and we replaced those with a 120 watt LED that provides better light quality, you know, more color, a higher CRI, color rendering index, better illumination, and much better efficiency at 120 watts. So it's less than a third of the energy usage. And then they also, like as you mentioned, the metal halide takes them 15 minutes for them to warm up and cool down after you turn them off. So you can't just turn them on and off if, you know, someone's leaving and going into the room evenly. So they would just stay on, and we noticed that. So so the lights that we have now are all have a 0 to 10 volt dimming capability, and that's set up with a sensor that is a controller that is able to adjust that light level based on things like occupancy and daylighting. So it's monitoring. It's a high base sensor that's installed up high, and it's monitoring the lighting levels, and then it'll adjust instantaneously the light level output of the light based on the skylight. So if a cloud comes over, those lights will brighten, and then, you know, automatically, yeah. So it's set into that. So right away, you know, you're looking at 1/3 of the energy used with the light, but then, you know, approximately, we're still collecting data on their performance, but it's approximately a 40-50% savings on top of that from the sensors and the controls.
Okay, so I'm going to stick with those lights, because, and I want to dig a little bit deeper, because every time I hear the word heat, I think energy loss. So you said that those original lights were also hotter and produced a lot of heat. What was the heat difference between what they're throwing out and what your LEDs are throwing out? Is it enough to affect the HVAC? I mean, were you able to save on cooling the building just by eliminating that heat factor?
On some of it, where actually the hangars, it's open ventilation, so and those are high enough where
so it kind of ventilated itself.
Okay. But yeah, I mean, the thing is about these old lights is that they're designed to contain the heat, and then, you know, I mean, they're just a very hot piece of metal. So these LEDs have much less loss to light, to heat. You know, sometimes 60-70% of the energy going into a light would be lost in heat for halogen and incandescent. So.
And how about life expectancy of the two different technologies? Are the old lights last about the same, or the LEDs much more?
The LED lights last an expected 50,000 hours. So so it's significantly more. It's you know, it's about I think it's sometimes 3 times or 4 times as long and as the existing light. So substantially longer, and that's because, you know, they're not under constant heat as well, and they're just more efficient type, the diode. So yeah, and all the interior lights that we installed, you know, we replaced some lights that were even fluorescent, put off more heat than LED.
Wow, I didn't know that.
So and, you know, a lot of times in our building we had fluorescent bulbs that we replaced with almost half the wattage. So whereas we had, you know, 32 watt fluorescent, we replaced those with a 18 watt LED tube light. So and then that one can also be controlled. So yeah, in the interior space, you know, having the LEDs replaced, that's going to help on the energy usage by.
Okay. Well, in the industry now, when you're retrofitting these buildings or looking at these buildings, is there any advantages to like splitting the power system and have some of it, like for example, you've got PV on the roof and it's making DC power. and LEDs could probably run off DC power. Is there any thought to maybe just staying with DC power for the lighting and just using AC power for like refrigerators and things that have motors in them that have different power requirements? Is there anything going on in that area?
There is, there's some very interesting, think tanks working on that. And yeah, you make a very good case. This is all DC. These lights are running, and as well, when you think about it, all of our devices, right? Computers, those all run
your cell
DC,
phone charger,
right?
your
Yeah,
cell phone.
so, everything is, a lot of that stuff is running in DC. I mean, it's almost like having to overhaul the system because, it's so set up for this alternating current use. But there is definitely, even, there's some organizations out there. One I've been working with, or kind of been involved with a little bit, is Emerge Alliance that does DC systems and buildings. So it's a pretty interesting area there. And as we move along to more, all LED lighting in buildings, and the electronics, DC electronics, and then there's definitely going to be an area, market for that. I think.
Okay.
It still hasn't, you see it more in like off-grid type scenarios, smaller, like, and boats and RVs and everything. Obviously, a lot of that's DC. So
Well, when you're running inverters, don't you actually lose a little bit of energy when you have to run inverters?
you do.
So if you're talking efficiency, maybe it'd be worth looking at setting up separate systems in a house if you have the luxury of starting from scratch and setting it up that way.
Yeah, because even in inverter is a lot of times 98, 98. You lose 3 or 4% a lot of times, for conversion. So you can avoid that and go straight to DC.
Great.
And just have like a voltage, a DC to DC converter for lower voltages, because typically the PV would be a higher voltage than your lighting and some of your other loads.
Okay. Well, believe it or not, we've blasted through 45 minutes already, and I liked hearing from you and learning more about HNU, and looking forward to, as new technology comes on board and energy efficiency, that maybe you can come back and spend some more time with us, and we'll go over some of your newer accomplishments a couple months down the road. So thanks for being with us today, Kyle, and that's it for my Friday, my lunch hour on Aloha Friday, and Stan Energy Man, and we'll hope that you'll come back and visit us next week, same time, same station, here on ThinkTech Hawaii. Aloha.